Greetings, warm welcome to everyone. Thanks to you for tuning in to this month's episode of the Houston Azure User Group, coming at you live from Katy. My name is Adam Hams, and I'm the leader of the Houston Azure User Group. Been doing this for, I think this is my 7th year running this now, this is my hobby, or one of them, if you will. This is my day job is as a cloud architect with Microsoft, a job I've been doing for 6-7 years now. So really enjoy it. I'm doing public cloud since 2013. So it's a passion of mine, or actually more specifically, what is a passion of mine working in AWS and Azure has been actually working with folks in the tech and business industries that actually just see the value of all the automation that public cloud brings. That's really sort of what everyone needs, something that like floats their boat, right? Gets them out of bed. And I've seen and helped folks walk the cloud journey, and it is a journey, as many of you know, from the beginning to some form of an end, a steady state in most cases, but an always evolving one. And seeing the folks, seeing individuals and businesses and companies and folks in all industries gain the benefits and learn and use it has been what really brings me a lot of personal satisfaction and joy. So something that I like doing as a job, and I like doing it in terms of community. One thing that I felt was missing, particularly here in Houston, was that sense of community learning from other businesses and companies that share the journey, if you will, the business need to gain from the automation that represents cloud, the IT or technical automation that represents public cloud, and gain and learn from that, but across all different industries, all different companies and size, sectors, similar security needs from finance and healthcare to lots of oil and gas folks and everything. And so that was one of the reasons I took over this group in 6 years ago, 2015, I think now. It had got a bit nascent. A few of the final meetups were sort of in a brewery and not very tech related, more about having a small party than actually coming together to learn anything. So we're here to learn from our presenter and from one another, and that's the intent of this group. So some of our best presentations have been when members of the community have presented, which is one of our which includes our presentation tonight, a repeat presenter, in fact, coming back for an encore. His first was so well received. And so one other thing that I wanted to highlight about that, something that's different about tonight's group. So COVID has made us all go virtual since March last year. I've done this for a year now. Fully virtual. It's been a learning experience, been a challenge, and we're doing this. We sort of got used to it, but as more and more folks get vaccinated here in Texas, it's all opening up. Was it next week? I think, Ravi, opening it up to everybody, and so yeah, more and more folks have been vaccinated. I've been vaccinated already, so more and more it's happening. More and more feels like the end is sort of coming, getting a little closer. So wondering what next, right? When we go back, do we go back to, certainly we're going to go back to some in-person meetings, but I have a question for the members here. Would you like to continue some form of virtual presentations? Now, we've never done this before in the time that I've been running this group, in order to encourage people to show up in person. Get in your car, show up and meet others, meet with the presenter. Obviously, we've had the technology, that's been easy. Technology is the easy part, but meeting people was certainly one of the key goals, something we wanted to encourage. Well, maybe things have changed. So a question for you, the members. Now, I intend to maybe put out create a little poll, and I'll send it out. But welcome feedback as to whether or not you would like us to record these sessions and stream them. Still have in person. I intend to redo that. We'll have that. but maybe we'll stream it and we'll record it. So folks who maybe choose not to, maybe prefer not to actually come into the office now for whatever reason, or you're unable to, time constraints, that doesn't work for you, or you just want to be able to just watch online, or maybe you're not in Houston. We have at least one person who's not in Houston, from Sweden, joining us today. We did have folks drive in from other cities, Dallas and Houston and Austin. Actually, folks drove in to our meetup previously, and now if we're streaming it, then of course that does open it up. Makes interaction a little trickier, but maybe that's what people would like in a post-COVID world. So that's something we're considering. And this event tonight, we're recording this one. So if you're watching the recording, nice to see you. Thank you. Let us know, and we welcome your feedback as to something you would like more of that. Okay, enough about our group. Let us hand over and begin our topic. Let's see, let's get Ravi's deck up. Building microservices with Azure Spring Cloud, a topic we've not covered before. Some topics we have covered more than once. This one we have not done. Without further ado, let me introduce you to tonight's presenter, Ravi Teller. Ravi, take it away, sir.
Hey, thank you, Adam. First and foremost, please do ask questions. Adam is monitoring the chat, so we will answer the questions appropriately, during this session or as a follow-up as well. With that said, one thing Adam mentioned, right? Cloud journey. Sometimes it might not be that straightforward, or it might take some time to get there because you have on-premises investment or a colo investment, or there could be some other concerns where you need to have a hybrid cloud, or maybe you just transition slowly. So we do in Azure provide a lot of on-ramps so that you can do things at your own pace, right? Be it hybrid or move things slowly to the cloud. So one such service is Azure Spring Cloud. As we go through this session, you'll understand why that is the case. For today, again, the focus is building distributed applications or small applications or microservices, whatever you want to call them, using Azure Spring Cloud. By no means it means that you have to build small applications or microservices. You could still build monolithic applications and deploy them to Spring Cloud as well, because that still is a great way of leveraging a cloud. So with that said, what we're going to talk today is about a Spring Boot. If you're a Java developer, or even if you're not a Java developer, you might have heard about it. We're also going to talk about Spring Cloud. I think a lot of people who might be using Spring Boot or Spring Framework or might not be, there is some confusion as to what Spring Cloud is. Personally, I think that name is confusing. When you hear Spring Cloud, you think it's some kind of cloud service. So I will demystify that. And then Steeltoe. Right? If you're a .NET developer, you might have heard about this. So we'll see why that is important in the context of Azure Spring Cloud. And then, why do we need Azure Spring Cloud? Right? You have Spring Boot, Spring Cloud, Steeltoe. Then what's the purpose of Azure Spring Cloud? Right? We'll review that, and then we'll do some demos. So that's where we'll spend most of our time today, and then review some possible use cases. Adam, can I move the slide, or is this something you move?
No, you have.
Okay, got it. I got it. All right, so I'm Ravi Teller, a software architect in the Houston MTC. I'm based out of KT. And these are a few links where you can look at some of the content I have. So the first link is my GitHub repository, and the image is what I have there. So in case there is any confusion, you guys should not have looking at this. So go ahead and get to that GitHub repository, because all the code from today is available in that repository, and many other repositories with the different sample applications. Plus, there is also a PDF version of this presentation available in that repository. So go ahead and make a note of it, or just open type the URL in the browser. And after that, you can also reach me on LinkedIn. My name is Ravi Teller, so LinkedIn /Ravi Teller, and you can also reach. I have started posting a few blog posts, so raviteller.com. use the Ghost platform to host them. So you can go check so my blogs out there. And also last one is actually one of the demo applications we are going to review and look at the code. It's a bookstore application, simple e-commerce website where you can buy books, nothing too sophisticated, but it is still a distributed application, and it serves well to show us the things you need to worry and how Spring Cloud can help in terms of building distributed applications. All right, so what is Spring? So Spring is a set of capabilities, libraries for building Java applications. So there could be a web application with a front end, or a server-side web application with a front end. It could be an API, or it could be a batch job. So you can use Spring framework to develop such applications. And it is quite popular. Like 52% of the developers, Java developers, use a Spring framework. And even if you go to Stack Overflow, you'll see many questions around Spring framework. And then within that Spring framework, we also have something called Spring Boot. It is an opinionated version of Spring framework. So what it does is it has strong opinions on how things should work. So the advantage of that is you can quickly build applications and deploy applications. So it relies a lot on auto configuration. So if you want to build an application and you're ready to sacrifice a little bit of control, but you want to do things quickly, then Spring Boot is the way to go. And just Spring Boot alone, it has around 52 million downloads in 2018, and then it almost doubled in 2019. I'm sure by 2020, it would have doubled once again. So the bottom line here is Spring Framework is quite popular, and a lot of developers use that, and Spring Boot made things even easier for many developers to quickly build applications. And this is not only big for small startups, but also big enterprise shops heavily use Spring Framework if they are into Java software development. So since it's such a huge user base who use Spring Framework, so over the last 6-7 years, we have been spending a lot of time on making Azure a great platform to run Spring or Spring Boot based applications. This included developing a lot of connectors, implementing database repositories for Azure services like Cosmos DB, Azure SQL, Postgres, MariaDB, and also many of our messaging services like Event Hub, Service Bus, and so on. And we also have connectors for integrating with Azure Active Directory, be it for internal applications, or if you would want to expose your application to the outside world and leverage B2C capabilities offered by Azure Active Directory. And we also have Azure Redis, which also has a implementation in Spring repository, which can be used to interact with our Azure Redis service. And we also have made some changes to our monitoring solutions, so your Spring applications can easily be monitored using our Azure monitoring capabilities. So net, we have invested a lot in terms of libraries to make your Spring Boot applications or Spring applications on Azure quite easy to build and execute. So for today, we are going to look at a e-commerce application, like I mentioned. It has a front end. It has 3 backend services: a cart, an order service, a customer service, and then all of the backend services are using Cosmos DB as their persistent store. So let me quickly show you how the UI looks like to make sure you understand that this is something real and not made up. So there are some books which are, okay, let's log into this. All right, there is a shopping cart capability. So you can come here, add a book to your shopping cart, and then you are hitting the shopping cart service. And then when you click on proceed to checkout, then you hit the order service. And then when you place the order, you complete that transaction, right? So for this purpose, this application, I think serves well because it's nicely distributed. And it also has a front end which depends on these backend services. So if we were to build, let's assume that we are building an application like this and deploying in any environment, be it on-prem or cloud, wherever it is, and we have a very high availability requirements and the performance requirements. So it's quite easy for anybody to just draw something like this, but as we all know, there is much more to it than just drawing a few boxes on the whiteboard. So what is that much more? So that much more would be this, right? So we need some infrastructure to actually run these applications. We will also need some kind of gateway, so which can actually load balance across these APIs. And we'll also need a front-end application, again, which is running on some virtual machine or a physical machine, which might again also have a load balancer, which is not depicted here. But more importantly, you'll also need some cross-cutting capabilities, such as a service registry, so that API gateway can figure out where the card service is or where the order service is. And also if there are any dependencies between order and card, then each of these services can reference by name. So we need some kind of a service registry. And we also need some kind of capability so that we can manage the configuration in a centralized way. Of course, if you're doing something, which is not production ready, you can always put your configuration in your application. But if you're doing at scale, multiple instances of the application and many different capabilities implemented individually, then you will need a centralized configuration server. And you'll also need a distributed tracing capability, because when you have, for example, here you have 3 card services, 3 order services, and 2 customer services, and the request on the front end can also be multiple instances. So you should have the ability to track a request coming from a particular front end instance, going to the gateway, and then going to a specific card service or order service or a customer service. So you need a capability where you can quickly query the data and isolate a transaction from all the way from the front end to the back end. So that's called a distributed tracing capability. So in summary, you need infrastructure, and also you need some platform level services like the runtime, the configuration management, service discovery, and monitoring capabilities for distributed tracing. And within the applications, if you are looking for high performance application, you also have to implement certain patterns. The green triangle here is basically depicting a circuit breaker. The idea here is, let's say if one of the backend services is taking too long to respond, abnormally long to respond, or if it's continuously throwing an error because maybe that instance is unable to get to a particular database, then your front-end application or the client application, which is calling that backend, should have an ability to stop sending requests to that specific instance, and that is called as opening the circuit. And then as the requests come in, it will half open the circuit and then sends few requests to that failing instance to check if that instance is again performing normally. And if it does, then it will close the circuit, and then the request starts going to that instance. Why that is very important is when you have an application which needs to be highly performant, then you cannot have a lot of requests from a client going to a specific service where the service is taking abnormally long time to respond, or the service has crashed completely, right? The problem with that is then you will have a lot of threads on the client side waiting on a response from the cart, and sooner or later you'll have some cascading failures because the client itself can start failing, and anything upstream will also start failing because of that slowness or errors that's happening downstream. So all these patterns, which are very common concerns of a distributed system, will have to be implemented if you want to build a distributed system which is reliable and performing consistently. So this is where Spring Cloud helps us. So what we talked about originally was Spring Boot, where you can build standalone applications be it an API, be it a front-end server-side application, or be it a batch job, right? Everything you do within the application, Spring Boot will help, even connecting to the databases and so on, or a messaging system. But the coordination between these applications, right? Service discovery, circuit breaker, intelligent routing, all those, or distributed tracing, all those are provided by Spring Cloud. So Spring Cloud is a set of libraries, which also includes the popular Netflix OSS libraries like Hystrix, Eureka, and so on, and additional libraries which Spring itself has developed together or packaged as Spring Cloud. So the name, I think sometimes for people who are new to Spring Framework get confused by the name Spring Cloud. So Spring Cloud doesn't mean it's a cloud service, but it means that you can build cloud native applications using the libraries provided by Spring Cloud. So again, Spring Boot is about building applications and connecting them to databases, whereas Spring Cloud is a set of libraries for creating distributed application and handling coordination between those each of those applications. So in other way, you can also think of Spring Boot as a .NET framework, right? Again, in .NET framework, you can develop various kinds of applications, including microservices. But the equivalent of Spring Cloud for .NET application is called Steeltoe. It provides all the capabilities which Spring Cloud libraries provide in the form of NuGet packages, and they're all open source, and Microsoft and many other organizations actively contribute to the Steeltoe projects. So they are right now available first-class citizen, and you can start using them in your .NET applications. So let's assume that you have decided, well, I like Spring Cloud capabilities. I like Spring Boot or .NET. And let me go ahead and implement a microservices-based distributed application with those specific requirements for a high availability and performance guaranteed. So what it would look like is right in the center here, right, where you see this blue line, this is where your applications will run, right, or your microservices will run. And then you will use Spring Cloud or Steeltoe capabilities to deploy a service registry and make your application talks to that service registry. Similarly, you will deploy a distributed logging capability called Schlut and Zipkin, right? You need to still deploy these applications and then configure your application to communicate with these services. All right. But the good thing here is you're not building your own service registry. You're not writing code to build your service registry or your distributed tracing capabilities or your distributed configuration server capability. These all come out of the box software modules, which you can deploy and just start consuming them. Similarly, you can also have a circuit breaker dashboard. This basically shows all your circuit breaker implementations and also the status, if they're open, half open, or closed, right? So pretty neat, right? Everything out of the box. You have to take that Spring Cloud or Steeltoe software and deploy them and create all these services and also use the client libraries for these services in your application to make everything work. You don't need to do anything more than that. But of course, when you look at this diagram, you might feel it's still complicated, Ravi. I still have to deploy a service registry. I still have to deploy a Zipkin server for distributed tracing. I still have to deploy a distributed config manager server, right? It's still quite cumbersome to manage all those, because ideally you would only want to worry about your code and nothing else, right? So what we did was, over the last 3 years, worked along with VMware to develop a product called Azure Spring Cloud, which is in Azure Cloud Service. So before that, let me ask you this question, Adam. So you saw all this here, right? Pretty cool. we have Spring Cloud or Steeltoe provides these capabilities, and you can deploy them as services and start consuming from your application, right? So maybe Adam thinks, oh, of course I can use bare metal or virtual machines or containers to actually deploy all those components and build my environment and deploy my application, right? It's a fair question. But the problem is it's still quite complicated, right? Because you still have to deploy the config server, deploy the circuit breaker dashboard, and also manage it by yourself, right? And somebody might even ask this question, okay, K8 is there, Kubernetes, it also has its own service registry inbuilt. It also has service discovery natively part of it, right? And potentially you can also use service mesh to implement circuit breaker and some other cross-cutting concerns. Yes, it's a valid argument, but then you'll be exposed to all the low-level primitives, right? Like in Kubernetes, then you need to understand what is a pod, create the Kubernetes deployment file, worry about the networking and all those things, right? So it's still quite complicated. So what we decided then is, why don't we build a service wherein you could deploy Steeltoe, .NET Steeltoe application or Spring Cloud application without worrying about the supporting services like the discovery service, the config manager, or the circuit breaker dashboard, and the distributed tracing Zipkin server. Right? What if we developed a service where you don't have to worry about all those things? When you create a service in Azure, all those services are managed by Azure itself, and you only have to deploy your code and configure your application to talk to these services. Right? That was the idea between Azure Spring Cloud. So with Azure Spring Cloud, the interesting thing is it actually runs on Kubernetes, right? But you're not exposed to any of it. And on top of that, we provide you all the services you need to run your application, like a service registry, a config server, right? And lifecycle management capabilities, auto scaling, and all those things. So basically, you will have two Kubernetes clusters. One will be running all the system services like service registry, config server, lifecycle management, and all those things. And one will be running your applications. The reason you see VMware Tanzu build server here is because we work closely with VMware, even though it's a first party product from Azure, Microsoft. We work closely with VMware, and some of their bits are also present in Azure Spring Cloud. So with this, what you get is you still, if you're a Java developer, you could just create a jar file and then push the jar file to Azure Spring Cloud. So, and within Spring Cloud, we take care of interacting with the Kubernetes, creating the pods and all that, right? You're not worried about that. You just create a jar file and push it to Azure Spring Cloud, and we take care of everything else. And we take care of providing all the services you need, like config server, service registry, historics, dashboard, and so on. And then, like I said, this is a joint effort with VMware and Microsoft engineers working together. And it is a first-party service with an SLA in Azure. Adam, any questions? I'll be jumping into demos.
Okay, no questions yet, but once again, remind folks, if you do have any, Q&A is open. Yeah, please punch it in for Ravi. So, Nani, Ravi, go for it.
All right, let's get into some demos here. So let's get into Azure portal. All right. So let's say I want to deploy a simple Hello World application into Azure Spring Cloud. So the first thing I need to do is I need to provision myself an Azure Spring Cloud instance. So let's go ahead and do that. So you're asking Azure, give me a Spring Cloud instance. So let's call it Meetup Spring Cloud. Okay.
Increase your font just a smidgen, Ravi.
Okay.
Zoom just a tad.
Better?
Yeah, thank you.
Okay. So I want to deploy it into US East. And then you have a pricing tier. You can use the basic or you can use the standard. So depending on that, you'll have some limits on how many apps can be, applications can be deployed to a specific instance of the service. For example, if you choose basic, you can have a maximum of 25 apps, but if you choose standard, you can go up to 55 individual apps. This could be APIs, web applications, so on and so forth. And also how much resource you can allocate to each application is also dependent on the maximum amount of resource based on which tier it is. Also, if you'd like to do a blue-green deployment, which I'll show you in a bit, then you would want to choose a standard tier. So with that said, let's choose basic for now. Okay, and then so we can enable analytics. I already have an environment where everything is enabled. So in the interest of time, I'll go ahead and disable these things for now or not want them. And as you can see, you can also actually deploy Azure Spring Cloud into your own virtual network as well if you choose to.
Hey, Ravi, I got a question on the network then. And a lot of enterprise customers don't like public IPs on their Spring Cloud. Does deploying it to a network allow us to not have that?
Yeah, you can deploy it into a virtual network like I showed. By default, it's exposed like app services as a public endpoint, but you can deploy it into a virtual network, yes.
But virtual network is private only, and then you access it only from the virtual network?
Right.
Got it. Nice. Thank you.
Yeah, remember, it's all underneath Kubernetes, so we can control all those things. All right, so while it is getting created, let's go ahead and use Spring Cloud. So I already have another instance of the Azure Spring Cloud. So as you can see, yeah.
Quick question. So yeah, Simone in Sweden asks, in production, those need to be enabled, which I take it, Simone, you're asking that the so I guess the question is what in production would we enable, which I take it would be not the basic tier, I suspect, Ravi. What other things would a production deployment typically have of Spring Cloud? I think that's what Simone's asking.
Yeah, I think for most production deployments, you would want to choose not, I mean, basic tier, for example, you cannot do blue-green deployments, right? So that is a limitation of the number of apps you can deploy. So with the standard tier, you get all those capabilities. So most customers we work with, they do prefer using the standard tier for production workloads. For dev tests, they use the basic. Does that answer the question?
Hopefully, Simone, if you have for more follow-ups, please post them. Meanwhile, Ravi, yeah, please carry on, mate.
Okay, so this is a existing Spring Cloud service instance I have, while the other one is creating. Let's look at this, right? So this is what it'll end up as Spring Cloud instance. So you can think of this as one environment. And then within that, you can have multiple apps, right? So the bookstore application is actually the front end is here, the card service and so on, and a few other things are here. So what I'll do now is, if I want to deploy something here, I need to first create an app. So first I need to create a Spring Cloud service instance, and then I need to create an app in here. So let me go ahead and create an app. So this time I'm going to use the command line. This might be quite small, I guess, but
yeah, it's a teeny bit teeny.
Okay, let me see what I can do. Okay, let me first run this command and then see what I can do. So basically what this is doing is this is creating an app in Azure Spring Cloud service, the RT Spring Cloud in the specific.
Can you read it out for us, maybe? What is it? Just real quick. What does it say?
Okay, let me otherwise see if I can copy paste it. Okay. Trying to open TextPad here. All right, so I think I'm having some trouble opening the TextPad. So basically what he's saying is AZ Spring Cloud app create and the name of the application, Hello Spring, and then the service name, RT Spring Cloud, and then the resource group name. And I'm also saying give it a public endpoint. So this is important, I think, Adam, because if you want, you can deploy an app even though it's not deployed, even though Spring Cloud service itself is not deployed into a virtual network. You can deploy app into Spring Cloud and say that that I don't want any public IP address. Then it's only be accessible within that cluster, but not outside. All right. Let's see if I can increase the font size. Better?
Yes, thank you.
I can make it even better. Excellent. Yeah. So yeah, Spring Cloud app create. So I'm asking, I'm using Azure CLI here. So I'm just asking an app to be created within a specific instance of the Spring Cloud. So there's nothing is being deployed, but it's just being created there. So while that's happening, let me show you the basic app here. Nothing too complicated. It's just a Hello World app. Okay. In fact, this just has one controller which just says welcome to Azure. And even if you see if you're a Java developer, this is the POM file. There's nothing more than the basic Spring Boot starter web for creating Spring app. Okay, there's nothing specific to Spring Cloud or anything here. It's just the basic app. And I can also run this app locally. Right, the same thing applies for even a .NET Core app.
I think if you do Control Plus, that's code, right? If you do, you got Visual Studio Code up. No.
Oh, this is actually IntelliJ.
Oh, okay. My bad.
Yeah. All right. And then let's go to localhost. And the app is running. It's just local. So the point I'm making here is just simple, nothing complicated, regular Spring Boot application. The same thing applies for .NET Core application. So once my app is created. Now, what I'll do is I will just build my app and create the jar file. So first thing I did is I created a Spring Cloud instance, and then service instance, and then added an app to it, Hello Spring. Right now, there is no code deployed to it, right? Only an app instance is created. And now locally, the Hello World application I have, I'm just building the jar file for that. So once that is done, now I'll be able to push this application to Spring Cloud. So this is the second command. This one basically says AZ Spring Cloud app -n, again, the name of the app, the name of the Spring Cloud service, and the local jar file which my build process had generated, right? In the case of .NET Core, it would be the zip file of your .NET Core application. So now I'm going to click enter here, and then it starts the deployment process. It should take a few seconds. And the beauty of this
while
is,
it does that, I have a question for you. So how did you authenticate with this AZ Spring Cloud?
yeah, I just AZ login.
Okay.
From command line. Yeah, AZ login, right, with your credentials, and then you set your subscription, and then you have access. So it's no different from any other access to any other resource in Azure.
Okay, all right. Not like Kubernetes then with kube.
No, that's the whole point, right? Because so you are using Kubernetes when you're using Spring Cloud, right, underneath, but you're not exposed to it.
Right.
The only thing is you're exposed to Azure CLI, and you're building a jar file. And that is nothing different. Even if you're using app service, it's the same concept. And building a jar file is the same, even if you're deploying locally, right? When I'm running on my own machine. So all that is completely abstracted away from you. Just pushing the jar file. And in case of .NET, it would be your zip file. All right.
Are there any Visual Studio, for those of us who like Visual Studio Code, are there any plugins, do you know, for this?
Yeah, Visual Studio Code has a plugin for Spring. So you can use that too. And so because you can develop, so there's nothing to, as long as you can develop a Java application, that's all is a requirement. Even in IntelliJ, I'm not doing anything other than having a Java development environment. So yes, IntelliJ, even in Visual Studio Code, it will work. In fact, there is no dependency of Azure or anything here. Okay. So while, okay, now it's deployed. So now we can go to Azure portal and refresh, and you have this Hello Spring application. And let's, this is the endpoint, because I said I want this exposed to a public endpoint. That's why I have this here. Right? Welcome to Spring. The same thing what we got locally, we are also seeing it here. So this is very simple, right? Only the jar file. So even if you have an existing application on-prem and you're not interested in using any of Azure Spring Cloud capabilities like client-side load balancing, service discovery, circuit breakers, then you can just bring your Spring Cloud application as it is, right? Give me a jar file and you can deploy. There's nothing else you need. It's still all work. All right. So let's do, yeah, and one more thing I can show. You can also, from the command line, we also have other monitoring capabilities, but you can also tail the log file for your application from a command line as well. Right, so it should show up in a second here. As you can see, this is coming from the server. So the whole point is you don't have to do anything substantially different from what you're doing when you're developing an application locally.
Nice. Okay, one question, Ravi. So asking about the AZ command, are there extensions you need to add for the Spring Cloud?
Yeah, Spring Cloud has an extension. You would have to add that. Yes, that's a good question. Yes.
Yeah, okay, thank you.
Okay, now let's do one more thing here. Let's go ahead and deploy another front-end application. So when we come here, as I told you, right, we looked at the e-commerce application, right? So what I'm going to do is I'm going to deploy another front-end application for that. And then I'll show you the code and then you can see the full power of Azure Spring Cloud. Remember, this front-end application is dependent on 3 other services: a customer service, a shopping cart service, and the order service. All right. So all of the customer service, cart service, and the order service are deployed. And this is the front-end application which I've just accessed. But what I'll do is I'll go ahead and deploy another application as a front-end application, the same code, but as another app. I already created an app here, user group front-end. But I only created an app here, so there's nothing there. So if you actually go and click on it, then you'll see nothing, right? Because no app is deployed. We just created an app, but we didn't deploy any code. So what I'll do now is I'll go ahead and deploy another instance of the app there. Okay. So that code will now go to the application called user group front end. All right. Again, this is the service and these are the apps. And now we can deploy code into the app. So let's go ahead and do that. Again, this is the same thing: Azure's AZ Spring Cloud deploy, the application name, the Spring Cloud service name, the resource group name, the resource group name, and also the jar file. Again, the jar file for the front-end application, which is residing on my local machine. So let's go ahead and do that.
So Ravi, while that deploys, we have a question around how DevOps might be in it, where you're manually doing this. I don't know if you can address that now or later, but we have a question about how do we use DevOps, get out actions, anything like that? So
we do have, you know what, by the way, this error is because I ran this command in the Hello World application command line. So it's obviously not able to find the front-end application, full-blown front-end application.
If you want to fix that, before answering our other question, Ravi.
Yeah, let me do that real quick here.
Thanks for the questions, everyone. Meanwhile, while Ravi fixes his stuff, please.
So we do, so I'm showing it from here so that it'll be easy to understand. So I showed a combination of, I need to see what's happening. I showed a combination of, okay, I know what's happening. I don't have the, okay. I don't have the jar file there. So let me go ahead and quickly run the package command. And then we should have, so you can use Azure DevOps or even GitHub completely to do CI/CD for Azure Spring Cloud, and we have full documentation available. You should be able to just Bing or Google Azure Spring Cloud and then go to a section where it talks about CI/CD. So there's a lot of examples there as well. Pretty straightforward. Again, remember this: we are just building a jar file in the case of Java application, and in the case of the .NET Core, we are building a zip file. So there's nothing different, right? So the regular stuff.
Okay. I have another question while that builds, Ravi. So I'll just read it out. I see the identity tab. I assume this service supports managed identity and can access all other resources using it that support managed identity.
Yes, it does support a managed identity. So it's a first class thing. Everything you do with other services, we have full support for it here. Now let's go ahead. And there are some clever ways of accessing other resources. So I will show you that in a bit here. So while this is happening, right? So what am I doing here? So I'm deploying an front-end application, another front-end application. So if we go back to this diagram here, right? So I'm deploying another instance of the front-end application. Now this application will have to talk to all these back-end services. And we also have circuit breaker implemented between all the services. And this front-end service also needs to get some configuration, which it needs. So it's talking to the configuration server as well. And then the front-end service itself registers itself to the service registry, and all these services are also registering to service registry. And the service registry is actually called open source project called Eureka from Netflix, which is now part of Spring Cloud and Steeltoe as well. Right. So I've just deployed this app, but then a lot of things should happen. But I didn't build any of these. Right. Only thing is I did a little bit of configuration for config dashboard, but and nothing else. So I'm not managing anything here. So let's go back to here. Okay. Then while this app is getting loaded, let's visit the other front end, which is already up and running. As you see the screen, these are the names of these applications. These are also the names by which if a front end wants to access this application, then it can just call it by this. This becomes its name by card service. So it's like a DNS name within the cluster itself. Or by cluster, it means it's in the context of a single Spring Cloud service. And so that's one thing that happens. So let's see how that actually happens in the code. So let me see if I can increase the font size here real quick. Any questions while I'm doing this, Adam?
Not anymore currently.
Okay.
One from me. So we don't get to see any Kubernetes clusters hiding in the Azure portal, right? They're just
That's a good question. So that's the whole point, right? You don't see anything. You're just interacting with Azure's Spring Cloud, and there is nothing that is exposed to you.
So what is put into the resource group? I see you've got
what into the resource group. Yeah. Okay, let's go ahead and look at that. In the resource group, I have a few other things, but the only thing needed is Spring Cloud service instance. So
you've got two instances in different regions.
Yeah, this one I just created in the beginning of the session to show you how to show everybody how we can create one to the portal. And I also have for the existing instance I previously had, I also enabled monitoring through application insights and logging through log analytics. So that's why you see both of them. And then I also have a availability test. My app insights is running from multiple different regions all around the world to check if my app is available from those regions. So that's why it's great. But otherwise, you only have Azure Spring Cloud instance, nothing else.
Interesting. Okay, we do have another question. How do we share state between different apps? Do we just persist to an external DB?
Yeah, persisting to the external DB is a recommended way of doing it, but potentially you could also have a local persistent store as well. which can then be accessed by other applications. So let me show you that here. Yeah. Right, you can also have a persistent storage configured just like Kubernetes, and then potentially have that shared. But generally, the recommended approach is, just don't put any state in the application, but defer that to external database or storage or something like that. Okay.
Yes, thank you, Ravi.
Excellent. Okay. Can you see this code here a little bit?
Just about. Bigger would be better if possible, but
yeah, it might occupy too. So yeah. So if you see this code, this is like the Hello World application. It's again another Spring Boot application, but since I want to use the Azure Spring Cloud capabilities for service discovery, distributed logging, circuit breaker, and all that, so I have imported some dependencies into this. In case of .NET, these are all available as NuGet packages. So I just import them, and now my application becomes a client to those services. So if you see here, I have a Netflix Eureka client. So this is for when I deploy my card service, and it registers itself by the name I give it, so that other services or other applications within that Spring Cloud instance can communicate with it. And as I said, I'm using a capability in Spring Boot called Fin client to connect to a REST service, or you can always directly connect to a REST service without using this, but this makes it declarative. But if you see here, I'm not giving it full physical address, HTTP, IP address, or something else. I'm giving it just the name of my card service. In this case, it's the card service itself. Another thing, if you notice here, I've also said there is a fallback. That's because if the card service is not available, because this is a front-end application, right? I'm calling the card service, and these are the methods that is getting called. And if that card service is not available, then it will defer it to the callback method. So in this case, let's say if I call get cart by clicking on the cart icon in the front-end app, and if the cart service is not available, then it will go to this fallback method and just return an empty cart, right? So no property says, just a new cart. And also, if there is a method which calls with the front-end application calls to retrieve the number of items in the cart. And again, if the backend service is not available, then the circuit is open, and then it sends me back -1 because I'm telling it to send me back -1. So that will be the default answer which comes back when a actual service is not available. And then in my application, I can then say that the certain service is not available, so try later or something like that. So I did the basic stuff here, but I could also make the circuit breaker work such that, let's say, I expect a latency between my front end and the card service to never be more than 10 microseconds or 20 microseconds, for example. And then if something goes more than 50 microseconds, then I can also say that open the circuit and don't send any requests back there, and only send some requests back there to check if the response is again within the range it should be. Right? All that can be configured. And this is part of the circuit breaker capability, which both Spring Cloud and also our Steeltoe for .NET provide. All right, so our application is now deployed, as you can see here. Now let's do one more thing. If you see the okay, let's see this the application code, right? And oftentimes you can have some configuration information within the application itself in the application.properties, just like app settings in a .NET case. But actually, lot of my application settings, including the database connection information and all that, they are coming from a GitHub repository. So I've configured a GitHub repository, which is private right now, and which I would want to be private. And I provided my database endpoint, the password, the database name, the specific database names I'm using, and also some logging capabilities which I wanted to enable. So what happens is Azure Spring Cloud, I have configured it to bring in these configuration properties from the private GitHub repository. And then when the applications start running, the Spring Cloud actually helps, because my application itself is using Spring Cloud libraries, then it can go and bring back this application configuration information. So now you have the advantage of putting your application configuration in a Git repository and get all the advantages of version control and all those, not just for your code, but your application configuration as well. And then if you have multiple applications which need the same configuration, you can share them as well. In my case, all the APIs are using the same configuration. So I have one configuration file in GitHub, which all my applications are actually using.
So Ravi, I guess for the password, you'd want to get that from a key vault ordinarily.
Yes. Right? Yeah, so that's another great question. So this, for simplicity, I've shown this capability, but Azure Spring Boot, or even if you're using Spring Boot, or if you're using a .NET Core, you have the ability to directly bring these credentials from Key Vault as well. And that definitely is a recommended way of doing it. But any other configuration which is not secrets, you can configure in a centralized way in a Git repository, either GitHub or any other Git compatible repository. Okay, so that's the configuration I have done right here. So for this Spring Cloud instance, I said, please bring the configuration information from this specific GitHub repository, but it doesn't have to be GitHub only, any Git repository is fine. All right. Now let's go ahead, and what we'll do now is let's go to this front-end app. Log into it. So now everything is, I can add items to the cart. I can delete items from the cart. So what happens if I, because I have the circuit breaker implemented, right? So now let me go ahead and delete or stop the cart service. I stop the cart service here. Now I'll go back to my application. So if you see, because my fallback method, when the backend service is not available, is sending back -1. Now the count is being shown as -1. But you can do something even better. Like for example, if you actually go into the cart, I received the fallback method's response, and I had an if statement saying if that's the response, then it's the fallback method, and I can just put a specific message saying shopping cart is temporarily unavailable, right? So it's pretty cool capability, because you just implement some logic using Spring Cloud libraries or Steeltoe, and everything works. You don't have to write hundreds of lines of code to make all this work. And when the service comes back up, then slowly this one will reset, the circuit will close, and you'll be getting back the actual service call. So you'll not see the fallback anymore. In addition to that, you can also, for each application, you can also scale out both manually, and you can also do it in an automated way as well. So let's take an example of this cart service. So right now I have one instance, but I can scale it up to, I don't want that many. Let's say 3 instances. Right.
And this instant counts, Ravi, this is up to the maximum provided by the tier you've chosen. Is that how that works?
No, there is the upper limit, but there's upper limit for the number of instances and also the number of apps you have deployed per Spring Cloud instance. Right. So this basically I'm saying, okay, add more instances of my cart service. Right. You can do auto scaling as well. Okay. So again, there is a Spring Cloud instance, and within that you can have one or more applications. Generally, the recommendation is if all the applications together, provide a functionality and end to end, then you can deploy them, all of them together. But all these services like the naming surveys, client-side load balancing, and all that, they work in the context of one Spring Boot application. For example, I cannot have another Spring Cloud service and deploy a .NET Core application or a Java application there and say I want to talk to cart service. Then it's not possible because that's a different cluster. Each Spring Cloud service instance is its own cluster. So you will not be able to reference one service running in a different cluster with by name. Then you'll have to go with a fully qualified DNS name or IP address. And another capability we also have is once you have an app, you can also have multiple deployments. This is what I said, right? If you choose the standard tier, then you have the ability to do this. Now you can, if you want to make a second deployment, call it green. So this is a production. And then you can set this as production, right? So again, blue-green deployment makes no downtime. You're just switching, making some DNS changes to make everything work. Right, and then if we go back, this -1 should now go away. Right, see, because now the service is up and available. Everything works. All right. Any questions?
One question, Ravi. So is there a hybrid story here? I think one of the viewers here has spotted that, caught up on the VMware mention that you had earlier. So do we have a hybrid story for running partly on-prem at all?
Yes, we do, because remember, so let me, yeah. At the end of the day, what you have seen, right, from an application development point of view, be it .NET or even Spring Boot application, everything you do the same. It's just that you're using some libraries, right? In the case of Java, you're using Spring Cloud libraries. If you want to, again, if you don't want to, then you don't have to write a simple application I deployed. If it's a monolithic application, you don't need service discovery, circuit breaker, then you can just deploy a jar file. But if you need to leverage these distributed design patterns or capabilities that Spring Cloud provides, then you're just adding certain libraries to your application and still deploying a jar or a zip file. So all these components right? Even including the Spring Cloud services can be deployed in a bare metal box, can be deployed in a virtual machine, on-prem, or in Kubernetes as well. Or VMware itself has a commercial product as well called VMware. You can see in the previous slide, Tanzu, TANZU. That's now what was previously used to be Pivotal Cloud Foundry, right? So yes, people can run this as a VMware commercial solution, or they are free to run the Spring Cloud kind of capabilities on their own infrastructure as well, without using a Tanzu server.
Okay, I think someone is asking, what are the differences when you run it in a bare metal or on a VMware hypervisor environment?
Yeah, so in that case, what happens is if you run it by yourself, then this stuff stays the same, right? You still write your applications and you deploy your application, but you will have to have some additional machines which can host the service registry, the config server, the circuit breaker dashboard, and all those things. So that software is available out of the box. So you're not coding the server side of the service registry, right? But you'll have to deploy that service registry software, which Spring Cloud or even Steeltoe provides in a virtual machines, and you'll have to manage it. That's the difference. But if you are willing to do that, you can do. In fact, some of the use cases I've been working on, we have a couple of customers, one oil and gas services company and one a shipping logistics company. So they have a scenario where the server side is completely running on with the Spring Boot and also .NET Steeltoe applications. But in case of the shipping company, they need most of their server side also to run on the vessel itself. So in the cloud, they're using Spring Cloud to run their .NET and Java workloads, and they're using Azure SQL and MariaDB as their backends. And the same workload, they're also running in their vessel on bare metal in some cases, and in some cases they're using Kubernetes as well. Right, so the advantage is you can pretty much, you don't have to change code or anything. You can run in Azure Cloud, there we manage everything. But if you're running in your own environment, then you will have to just provision some additional virtual machines and then create the service registry using the bits provided by Spring Cloud or Steeltoe.
Okay, did you mention MongoDB? Simone is asking if you need to build that separately and migrate it if you're using MongoDB.
No, the databases are, see, the way you have a Spring Boot application or you have a .NET Core application, right? They might be connecting to a MongoDB. So that part doesn't change at all. The way you connect to the database, it still says the same, right? Still is the same. So you don't have to worry about changing anything with respect to that.
Or necessarily moving it, I guess. If you're using MongoDB in Azure and you expose it via ExpressRoute, you can talk to it from a on-prem run Spring Cloud, or the other way around, I guess, right? If you run Azure Spring Cloud, talk to MongoDB on-prem as long as you've got ExpressRoute and you deploy to a VNet.
Exactly. Yes, I think the main point I think is here is you can use Azure Spring Cloud where you can just deploy your application and we take care of the virtual machines, we take care about the monitoring, management, and all that, and we also provide the services which your application needs, right? Like a service registry, circuit breaker dashboards, config servers, distributed logging server, and all those things. But all that software can also be installed wherever you want, right? Be it, you can actually deploy all of that in your own laptop as well. So we have another customer we are working with. They have only, so they have the server side where they run .NET and Java in Spring Cloud. And on the edge, they have only machines between 8 to 16 GB. So they're running a scaled down version of the Spring Cloud applications, which are both .NET and also Java. in that 16 GB machine by provisioning their own config server, service history, and all that. Right. So that's the beauty of it. You can take this anywhere you would want to.
Okay, got it. Thank you, Ravi. No more questions.
Okay. And then, like I said repeatedly, underneath it's all Kubernetes. But who cares, right? You're just pushing your zip file or your jar file and adding some libraries. Other than that, when you're using Azure Spring Cloud, you don't have to do anything, and you get all the capabilities you need to implement a distributed application. And again, if you have a need to run the same on-prem, you can use a VMware Transit server, or you can take the bits and create your own cluster in any kind of machine, as small as a single laptop, or it could be a big server farm. It's up to you. Right, and Azure Spring Cloud is available across most Azure regions, so you should feel pretty comfortable to actually make global deployments as well. So one other thing to wrap it up, right? So we also remember I talked about logging. So all of this is integrated into our native monitoring capabilities. So App Insights is for our application monitoring. So it collects all the telemetry from the applications, and it actually creates a map of an application map of the database and how all the applications are interconnected between them. And we also have live metrics to monitor your applications. So any live activity that's happening, you can start seeing right here. So let's say if we just go to a page here, you should see some action happening here. And remember, I told you I also configured an availability test. So basically, what once you configure an availability test, it could be as simple as just doing a ping, or it could be more advanced, like retrieving some data and validating the right data has been received. So, so I did a simple ping test, and I said that just hit the home page from 5 regions, all around US, and also a couple outside, a couple in Europe. So it's continuously does that every 5 minutes because I've configured so. And if let's say the availability is below 100%, then it'll send me some alerts. And you can also see top failures from your application. So it's 404. I think it's mostly because I was getting an error because I shut down the cart service, right? So some of those errors are showing up here. And then you can get access to all the application logs through App Insights workspace right here. The page views, requests, trace, dependencies, and the metrics associated with the CPU, memory, performance counter, perf counters, and all those things.
Okay, another question for you, Ravi. Can you apply, can you use API management maybe in front of this? And also, well, I guess the question is also around the customer wants to apply IP restrictions using whatever. How might a customer do IP restrictions or front end it with an APIM?
Yeah, you can definitely, because all these services are exposed as, I mean, so for example, if you go back to this example, same example, right? This API gateway could be a API management as well. So it all depends. So in my case, the cart, order, and customer, they don't, if I don't want to expose them to the outside world, because I have my front-end application and all the backends running in the same Azure Spring instance, then there might not be a need to put an external API management capability. But let's say this cart service I want to expose to a third party. right? Because it's so cool that others can use, then definitely you can put API management, expose the card service on a public IP or even in a private IP, and then lock it to a virtual network and have API management in front of it. And then API management will have access to that virtual network to reach the card service. So there are some scenarios why you want to use that, because then you can apply throttling, you can apply result caching, and all those good things.
What about an application gateway? Put a WAF in front of it. Where?
Of course, yeah. So everything. So these things are exposed as REST. I mean, if you're building a cart REST service, right? Anything you could do in front of it, putting additional load balancer outside, like Azure load balancer, or putting WAF, or putting API management. Everything is possible. Or even if you want to put front door, all that is possible.
Okay, thanks, Ravi. No more questions.
You're welcome.
Just yet. I saw you can use custom domain names. I saw that in the UI when you showed us that.
Mm-hmm. Yeah, custom domain name. Yeah, there is really no limitations in terms of what you can or what you would want to do. But the whole thing is, again, it's quite simple. Like we all know, like Kubernetes, sometimes it's quite intimidating, right? Here, without getting into that complexity, you can still use Kubernetes and still get many of the design patterns that you would want to implement in a distributed system out of the box. And in Kubernetes, you can do a lot of these things, service discovery, circuit breaker, but there you need to implement Istio or some other service mesh and all those things, and you'll have to manage that. But here, it comes right out of the box.
No Helm charts. What's up with that? Not even one.
Yeah, you don't need anything, just a jar file or a zip file. Nothing. Azure CLI. So again, there's some links. I already shared the GitHub repository of for the application I demonstrated. I'll upload some instructions there. Beyond that, like if you downloaded the slides, you can also look at our YouTube channel, some other additional demos, workshops, and quick starts, including the one for CI/CD as well. Any additional questions?
I think I've been getting most of them as we go. I think one question is around, they're trying to understand a bit more about the incoming IP restrictions. So yeah, so I think one clarifying thing, Ravi, is that you would need to deploy your Spring Boot cluster there to a VNet in order to do all the IP restrictions, right? Or can you apply IP restrictions on the internet-facing one, like you would on function apps, on web apps?
Let's check that. So I am also not 100% because I've deployed into a virtual network, and then you can control. Right. So one thing we know 100%, I know, is that when you deploy an app, you can choose if that app should have a public endpoint or not. Okay. So for example, let's see this screen. So when I'm, so not when deploying, actually, when I'm creating an app, right? So first I need to create an app in Azure Spring. So I create a Spring Cloud instance, right? And then I create an app in that Spring Cloud instance. So when I'm creating that app, right, then I can tell it, should it have a public IP or not? If I say it should not have, then it will only be accessible from within the cluster itself or within that Spring. So any application which is running within that Spring Cloud instance, only that application can access a service which doesn't have a public IP. So that thing we know. And as far as restricting by IPs, I don't think it might be possible. I think it's only possible to put it in a virtual network and make that happen.
Yeah, I'm just checking the docs as well. I don't see that out of the box. So just to clarify, I think the question that we have here is it like function apps or web apps where the internet-facing versions of those services can have IP restrictions as part of their firewall. That's not a feature with Spring Cloud out of the box. You'll need to deploy it, I guess, in a private VNet, no public IPs, right? And then put another service in front of this, I guess, and then put IP restrictions on that. That's what it looks like to me.
Yeah, or it could be at the network level for that virtual network.
Yeah, using NSG on the network, perhaps.
Yeah,
you could do that. Okay. All right, that's a good question. We all learned something. Any other questions, anyone? Don't see any. Are there any other features on the portal you didn't walk us through? So you can do your own SSL certificates for the public-facing stuff out of the box. I think they're Ravi, right?
Yeah, all that can be done right
Just,
here.
I saw TLS SSL settings. Yeah, you show us that real quick. Okay, you upload a cert presumably.
Yeah.
Or pull one from a key vault.
From the key vault. Yeah.
Oh, even better. Okay, great.
Yeah, and then you can use that. Here.
Then you say a custom domain. Okay.
Yeah. At the app level, each app level you can do that. Yeah.
Okay. You can. I see you can set HTTPS only. That's good. A lot of customers want that.
Yeah.
Okay. Actually, we have another question. Can you give us some insights on the underlying infrastructure? Mike comments that the Azure portal interfaces you're showing have a similar feel to that of Azure App Service. So Spring Cloud, what's it backed by? He suggests, is it backed by VMware running on Azure's bare metal? What can you share with us?
No. Like I said, one of the slides I have here. Right. So this is how it is. So it runs on Kubernetes, and then there'll be two Kubernetes clusters. And again, this can change, but right now how it is like this, because this is all completely abstracted from you, right? In one cluster, you'll have the services which are applications rely for distributed coordination, right? Service registry, config server, and so on. Another other cluster is where you deploy your apps. Right?
So
inside.
Go ahead.
Yeah, so inside, so when you deploy an app in the background, we actually create a Kubernetes deployment, and they get deployed at pods, because ultimately it is running as pods in Kubernetes. So that all happens. If you guys are familiar with Cloud Foundry, there's a concept called a droplet. It's the same concept applies here. You're just pushing your JAS. So think of, instead of we asking you to create a Kubernetes deployment, we are saying just give us that, and we will take care of doing what needs to be done, right? Maybe if tomorrow we find something better than Kubernetes, then we might use that too. But for now, we are using Azure Kubernetes Service.
Okay, and this is a shared Azure Kubernetes service, presumably, Ravi. That's not like an individual cluster stood up in the end user subscription, or is it? That's just hidden.
Yeah, it is hidden. You'll know. So from when you ask Azure to provision you a Spring Cloud service, then you only have a Spring Cloud service instance. You will not see anything else, any other resources or created. You'll not see a Kubernetes cluster or anything. It's all abstracted from you. So that is good. I think the whole point is just simplify everything. But when Spring Cloud capabilities, Steeltoe, and all this, right? Mainly, .NET Core is there, Spring Boot is there. That's okay, right? We all know. But what the Spring Cloud or Steeltoe, what they have done is, these capabilities were developed even before Kubernetes and Docker became big. So a lot of this comes from the early days of Netflix. then they were running their distributed applications, right? Obviously, you know the scale they run it on virtual machines. So at that point, Kubernetes was not that big. So they started developing these libraries for handling scenarios for service discovery, circuit breakers, distributed tracing, client-side load balancing. They wanted those capabilities, but they wanted it's all software driven, right? They didn't want a hardware load balancer or something like that. So they developed this different libraries for their internal use, and then they open sourced them. So then the open source community took them up, and then they became part of Spring Cloud and Steeltoe. So that's why to run this environment, right, it is not like all or nothing, or it is not that you only need a Kubernetes runtime, Kubernetes orchestration, or a Docker Swarm, or bare. You can do it, run it wherever you would want to. So the software is abstracted away from the hardware or the orchestrator or everything. That's why you could run wherever you would want to.
Okay, I think that answers the question. Yeah, to further clarify Mike's question, yeah, so it's not VMware or Azure's bare metal. It's Kubernetes clusters, which are all on Linux VMs.
Yes.
Another question we had was when you created the Spring Cloud service, you chose a tier, standard or basic, I think what it was. Mm-hmm. And there's an ask about the number of machines underneath that. Is there a way to configure how many virtual machines are underneath?
No, you only, we only expose either you choose the basic or the standard, and then we say, okay, if it is standard, you can go up to, let's say 200 applications. And then we also say that each application can have a maximum of this much CPU and memory. So only that is exposed to you. How do we place them on virtual machines is a more implementation detail. So you don't have a control. So again, if you go to Kubernetes, you have more control, but here the whole point is you do sacrifice some control, but you're getting rapid application deployment and less overhead in terms of managing the platform itself.
Okay, thank you, Ravi.
In fact, you can actually, it's quite, you could envision somebody provisioning a Kubernetes service and deploying these things on top of Kubernetes and making their own.
Yeah, you can do it yourself, right? If you can do it on-prem, then you can just
right. You can do it on your own laptop.
Actually, the same way if you did Kubernetes, right? I mean, you could just stand up some Linux VMs in Azure, install Kubernetes on it, build up your own cluster. Yeah, if you're a real masochist.
Or you on your own laptop as well. And that's the actual scenario, right? We have a lot of customers who have need edge capabilities, and they are running Kubernetes on the edge. And there are some customers who are also running Spring Cloud capabilities on the edge, especially in oil and gas industry.
Yes. Yep, indeed. Okay. So any more questions? Don't see any other questions. Okay. I think that might be it. Still got a room full of folks. So, but I think no more questions. If anyone else does have any, then pop them in the chat. But we can get to them in a minute. But I think that might be it. In which case, thank you, Ravi. We will call it an evening. Successful presentation.
Great. Thank you. Thank you, everybody.
And so we're going to pass we'll post the deck onto the Meetup, Ravi, right? We can do that.
Yeah, we can do that. Yeah.
Okay. Yeah. All right. So I'll if Ravi, if you share with me the deck, I'll post it for folks who didn't get your links that you shared and such like. I did post your GitHub in the chat here, but I'm sure folks would want that in your deck. So yeah, for everyone, check the Meetup comments, not the session tonight. We will post those, post the deck there for you to download. And so that will conclude our session tonight. Thank you all for tuning in all around the world, in this case tonight, coming at you live from KD, Texas. And that concludes the March edition. We would like the feedback of folks here as to whether or not, once, as we get nearer the end of COVID and we're all comfortable with meeting in person just like we used to, would you like the option of streaming our in-person events in going forward in the future? We've not done that before. Is that something that you would like? Would you like that, or even catching the recordings like we have here tonight? Let us know. Actually, we'll send out a survey, or you can put comments in the chat for this meetup. But thank you all very much for joining. Thank you, Ravi, for our speaker. Thank you all for our questions. Stay safe, everyone, and we'll see you next month.
Thank you.